Good morning, everyone, and welcome once again to the group exhibit Hydrogen and Fuel Cells at Hanover Fair 2012. Please do come in and sit down. We have much room and many free drinks. We have an interesting subject for you to start off the day called Smart DC-DC Converters, Techniques for the Energy Industry. And with me, I have the sales manager of Central Electric, Stefan Wessendorf. Please join me in welcoming him on stage.
Thanks to the colleagues here.
A little biased.
Hello, good morning.
Welcome.
Yeah, hello.
So you're not new to this fair. You've been here almost as long as it's been going, the full 18 years.
Yes, Central Electric is, let's say, exhibitor since more than 10 years. So we are every year here and on stage, and that's nice.
Well, welcome back.
Good.
So how is it that your company came to visit this fair and be placed in this exhibit?
Okay, Central Electric is developing a lot of things for the energy industry, mainly DC-DC converters, but also we started with the fuel cells, especially more than 15 years ago with DC loads for the hydrogen, for testing equipment for the automotive industry. Daimler is one of our customers, so we test fuel cell stacks, and this was starting with, let's say, fuel cells, but our major market is, let's say, the total energy utility industry.
So you have a long tradition with us here at the Hanover Fair.
Absolutely.
But your company itself is quite old as well, isn't it?
Yeah, Central Electric is founded, let's say, more than 50 years ago. So we are in the field of energy, of power since these times.
And it's actually second generation family owned, isn't it?
Yes, it's a family owned company. So we are small but powerful and working in this field with, let's say, all emphasis we have.
And strong traditions in the field, but this year you're presenting a newer product, the Start DC-DC converter.
Yeah. Okay.
Yeah, what makes it smart?
What makes it smart? The thing is, if you work, let's say, in the utility industry, everybody expects you to develop products that have long-term stability, etc. But let's say our view on these things is that in the power industry you have much more situations that the grid is not stable. That brings effort to all secondary and all components in line. So Central Electric has this in mind. You can calculate MTBFs, etc., have real statistics, but I think everybody wants to know what is a component doing, what is their actual life cycle.
So the mean time between failures.
Yeah, this is MTBF, and everybody gives these figures, but I think this is a statistical value, but you have to know what happens in reality, and therefore we want to measure our converters in the system. We are not, let's say, on the main line. We are in the secondary stage for the safety and backup systems. That means smaller DC-DC converters, and therefore I think if you want to have backup systems, you need to have them running.
So you put some brains in the device so you can monitor what it's doing?
Yeah, that's the point. We monitor. We look inside our converters to look for the temperature, for overheating, for overvoltage, etc. All things you can measure. This is the main idea of this product.
And who cares for this information?
Okay, care for this information is, let's say, on side of let's say, of the user. He can go directly inside the system via an open communication. We can do this via CAN bus or others. So this is depending on the demand of the customer.
And why might the customer want to know this information?
Everybody knows it from the automotive industry. Yes, you have to know what your engine is doing. So we say, okay, at the moment everybody knows only from a converter it's alive or it's dead. You need behind all the things measurement equipment, and we say, okay, we want to look inside and give the maintenance of the customer the possibility to look inside, to measure all these things, to have the information directly via Ethernet or whatever. And I think this will be the major point for the future, that each and every component will be controlled, must be controlled.
So do you collect the information as well, and would you use it to design your product better in future?
Okay, this is a possibility if the customer allows us to measure these data too, then we can do it. In terms of maintenance, we can get the DC-DC converters back, read out the data, so we can have some information about the life cycle of the product, and give this feedback to the customer to have, let's say, real monitoring and real maintenance information for him.
So it seems like there's a lot of features added, a lot of functionality.
Absolutely.
But with that comes cost.
Okay, if you look for the cost, nothing is for nothing. But I think if you look for the total cost of ownership, you can reduce your warranty, your maintenance costs, because you have remote control possibilities. This is one thing. You have maybe no problems on site. You have reduction, let's say, in your life cycle, and this is the main feature, that you can reduce your cost on, let's say, 25 years for a product like this.
So you can see before your product starts to go, maybe do some preventative maintenance rather than killing it.
That's right. If you look for overheating or something like this, then you can, let's say, have your own calculations. The maintenance of the customer, maintenance services of the customer can get into the system before it might be dead. Yeah.
So you mentioned that you thought this is a trend that most other components, balance of plant components, will also have this?
I'm sure, and therefore everybody is working on communication systems. So if we think about the total management of systems, then you have a structure that you want to know from each and every component, from each and every electrical device, what is it doing, and so therefore we have to think, and we have to be smart and be a step ahead of others.
So do you think this is, well, it's necessary because the grid's more intermittent, the power supplies are less known, what it does to all the components is, there's more stresses put on them than more traditional systems. So, but is this just a temporary necessity then, while we learn more about these systems, or is this a permanent change? This is how the industry is going, is to put more intelligence into the devices.
I'm sure that this will be a tendency and a trend that will last for years, because we have the situation that everybody talks from a smart grid, but a smart grid can only work with smart components. So if we want to have information each and everywhere available 24 hours, 7 days a week, then you have to have a look inside your systems, inside your control units.
So let's talk a little about the applications, which systems it's best suited for, or maybe it's open for any systems.
No, let's say open for every system means if we are installed in a hydrogen backup system, or in a backup system with lithium-ion batteries, or with, let's say, standard accus. This is a question of the design of the converters. This is possible to do on customer request. The major thing is that we have an open technology, so that we can provide every service to everybody.
So you have a standard black box, let's say.
Yes, we have a standardized processor inside, so we are able to do this for, let's say, each and every technology.
So where might these technologies be implemented? I mean, I can see definitely for remote off-grid locations, being able to see what your system is doing from far away is very helpful.
Yeah.
But would you put it in more close-by systems and central systems as well?
Depends on customer demand, I would say. I think the first idea was given if you have, let's say, systems or units where you are where you have to work, let's say, in the mountains, in the hill, where you have problems to go there, you have to control these systems. So customer demands came from that side, that they want to know what the things are doing and they want to reduce their maintenance costs. This was, let's say, the major idea in the first step. But when we, let's say, thought more and more and go into details on that, we saw that the demand is to have it, let's say, in each and every stage of a system.
So for electronic components, it's always a question, well, you want the maximum efficiency possible.
Absolutely. This is for sure. Everybody wants to have nearly 100% efficiency. That's right. And we, let's say, talk about an efficiency of more than 95%. This has to be proved by the customer, but the Centro products are proved on that.
Would it be possible, with gathering all this information, to be able to see which scenarios you're most efficient in and less efficient in, depending on what power is coming in, well, what voltage is coming in?
Yeah, you measure a lot of, let's say, details in the system. A DC-DC converter, you talk on voltages, you talk on power, you talk on temperature. You have to save these data in a special processor, and you can read them out and get remote control on that.
So your component being a balance of plant component, it's do you find it's often neglected? I mean, fuel cells and hydrogen is, I guess, the sexy part of the system.
Okay, I would say yes, for sure.
So any questions from the audience before we continue? Okay. So since we have a little bit more time, I'd like to hear a bit more about the other products that you offer at Centro Electric.
Okay. Talking about this, we have on one hand the electronic load banks for the fuel cells industry, but also for other test equipment for electronic devices, from power supplies, laboratory power supplies. I think if you are engineer mainly in Germany or in let's say Europe, then you work with Centro power supplies in your lab when you study. Everybody knows those products. This is something that we produce and manufacture and develop since years, and have always special requests on customer demand to do special things. For example, if you look here to the people from the DLR, they use since 10-15 years our loads for their special fuel cell tests, or now also for the electrolysis control units. On the other hand, products also for the renewable in the e-mobility field. We do also battery chargers for let's say special application, not the pedelecs, but special applications in the e-mobility. And third one is the DC-DC converter business, from let's say the standard units up to units that have this smart information inside. And this is the first step in a new product family, and I hope you like those things.
What other industries do these different products work in?
Our products are working in the automotive industry, in all test and lab industries. If you make your, let's say, stock entrance tests or whatever, then you do this with Centro products. So we serve, let's say, all industries, from electronics to automotive to machinery automation.
And do you find the energy market and the demands that we put on you, is this the most challenging, or?
Yes, because it's driven by the people. Everybody knows that our energy will end up in some years, so we have to have smart ideas and we have to develop things, and therefore it's for us a must to be in there and to go forward.
Well, not often the first thought of when hydrogen and fuel cells are thought of, but a very important job, a very important support that you give, and I'm glad you're up for the challenge.
Yeah, we go for that, and therefore we are here because every year when we talk to the people here, we get new ideas. We have some information about market situation. We feel what's going on.
So you've got a good impression from the people this year?
Yes, and you see. If we go here through the fuel cells business, everybody talks on this. We have all the years movements in the past. We saw it goes down, now it goes a bit ahead. The direction is not clear, but Centro is open for that, and if we get requests on these points, we will go for that.
You're not willing to make a guess at what comes next?
No, I'm not the prophet.
But you'll come back again to us next year.
Absolutely.
Great.
Thank you.
If there are any other questions from the audience? Yeah.
Hello.
You was talking about the electromobile industry.
Yes.
If you look the different cars, they have all different power. Starting with 48 volts up to 300 volts, something. They are stored in the battery. And to charge these batteries with solar or windcraft means you start on the primary side with 300, 400 volts.
Yeah.
On the other hand side, you can have very low voltage or also high voltage.
You have this.
Are you prepared for such DC-DC converters?
We have both in our program, and we have both demands from customers.
Yeah, then we should talk together.
Okay,
Thank you very much.
Any other questions?
This is always a question of the philosophy of the customer, which way he goes, and we have demands on that and on that side.
Great. Any other questions? So if there's no more questions, please do come visit him at his booth. He is over at, it's E65, isn't it?
D58.
Oh, my goodness,
And we have
I'm sorry.
also some press releases from this new product, but you can come over and see it.
Yes. We'll hand them out here as well. So D58, it's just over in that direction. Please help me in thanking our wonderful speaker.
Thank you. Thanks, Karen.
Thank you. So please do stick around. We have a talk here that wasn't on the schedule originally in auf Deutsch. Wir haben Dr. Ulrich Schmidtchen von die Deutsche Wasserstoff-Brennstoffzelle-Verband. Gibt einen Vortrag über Wasserstoff- und Brennstoffzellen, Potenzial und Wirkung. Dankeschön.